Olanzapine, or Zyprexa, is one of the most commonly prescribed antipsychotics in the world, commonly used to treat conditions like schizophrenia and bipolar disorder. Instead of just listing its effects, let's look at what it's actually doing in the brain, and why those effects happen. I should mention, I'm not a psychiatrist or neurologist myself, but I've done extensive research and have been on this medication myself. When olanzapine is absorbed through the bloodstream, it begins a journey, ending at your brain. Once inside the brain, it starts interacting with receptors on neurons, particularly dopamine and serotonin receptors. Neurons communicate using chemical messengers called neurotransmitters, and these messengers bind to specific receptors. Olanzapine works by binding to some of these receptors itself, blocking or altering how those signals are transmitted. Dopamine is a neurotransmitter that helps the brain decide what's important. It plays a key role in motivation, attention, and something called salience, which is basically how much significance the brain assigns to a thought, feeling, or perception. The olanzapine binds to dopamine D2 receptors, the sites where dopamine would normally attach, and reduces how strongly dopamine can signal between neurons. Since dopamine helps the brain decide what's important, reducing that signal can lower the chance of the brain assigning too much significance to thoughts or perceptions, which may help explain why symptoms like hallucinations and delusions decrease. Olanzapine also interacts with another major neurotransmitter system, serotonin. Serotonin is another chemical messenger in the brain, involved in regulating mood, emotional stability, cognition, and how we process information. It helps shape how we interpret experiences and how the brain filters emotional and sensory input. Olanzapine binds to several serotonin receptors, most notably the 5-HT2A receptor, which is thought to influence both perception and cognition. The olanzapine blocks these receptors too, which tends to reduce overly intense or disorganized cortical activity. Combined, the blocking of these dopamine and serotonin receptors can reduce hallucinations and delusions, and help stabilize disordered thinking. It can also reduce what's called psychomotor agitation, things like extreme restlessness, racing thoughts, or manic behaviour in some cases. Olanzapine was designed to target these certain receptors, but drugs rarely bind to only one receptor type. Its molecular shape also allows it to bind to other receptors that have similar binding sites, which is the cause of many of the medication's side effects. One of which side effects is sedation, which is largely caused because of its blocking of histamine receptors, which regulate alertness and wakefulness. It also interacts with receptors involved in appetite, often leading to weight gain, although I actually had a reduced appetite when I was on them, which isn't as commonly documented. Its interference with dopamine and serotonin receptors can also cause emotional blunting. My personal experience with olanzapine was frankly awful. I had a really bad flat effect and I slept about 16 hours a day. If you experience strong negative effects from olanzapine, you can ask your prescriber to move you to a different antipsychotic. I was moved from olanzapine to aripiprazole, which works quite differently to olanzapine but carries its own side effects on the opposite side of the spectrum. So then I was moved to risperidone, which I didn't experience any side effects from. I plan on explaining the mechanisms of other medications, so subscribe for more similar videos, or you can browse the channel as the Sanctum has many subjects to offer. See you in the next one.